Now we are going to learn the concept of movement time between the locations. So far, every model that we develop, if the parts go from one location to another, we assume that that transition happens in no time. So the part immediately goes from material receiving to inspection machine, any one of them. When they're done at inspection machines and they want to go to packing, that transition happens in no time. Immediately, if the packing machine is empty, they immediately go to the packing machine. However, in real world, that's not always the case, or most of the time it's not the case. If there are two locations, two machines, they have some distance from each other, and it takes time for one part that is done in the first machine to go to the second machine. So there is some time associated with this movement going from one location to another. So that's the movement time, or that's the move time we want to be able to capture, because that makes our model more realistic. So to be able to do that, this part of the processes move logic is the part that helps us to capture any move time that may be in our model. So let's assume here there is 3 minutes fixed, 3 minutes move time for going from any location to the other, going from material receiving to any one of these inspections, and going from any one of these inspections to the packing. Okay, let's assume there is 3 minutes fixed move time. We can identify that in the move logic window. So here I can write move for 3. Or I can write move for 3 minutes, but I don't have to write minutes because the default unit of time is minutes. So if I just write move for 3, that's fine too. Okay. So, and all I need to do is just copy this for all the movements that happens in this system, in every line. And first line, second line, sorry, for the, no, just pay attention that for the line, when the entities go from packing to exit, we do not put any move time, because that exit just is the exit for the simulation model, for the Pro model. So the entities leave the system in Pro model, but that's not the real exit in the system, in the actual physical system. The real exit in the actual system, or the real end in the actual system, is when they get to packing. That's all we care about when we wanted to model this system. So we do not put any move time when the parts go from whatever location to exit. That's meaningless. We do not put move time for that one. But for anything else, we do put the move time. Okay. So put the move time for anything, all the lines. And here the move time is fixed 3 minutes, so that's all I put. And then run it. Now I see the number of exits. If we go to the entity summary, we also see some time in the move logic, something we didn't have before. So there is also some time in the movement. And as you can see here, entities have only 2 movements, one going from material receiving to inspection, and then from inspection to packing. Each one of them is exactly 3 minutes. That's why the time in movement, or in move logic, is exactly 6 minutes, and that's correct. So then the time in system that we see is the sum of the operation time, wait time, if there is any, block time, and move time. So when there is move time associated with moving entities between different locations, obviously that affects the time that the entities end up spending in the system. So we want to be able to capture that. So if we have forklifts to move the parts around, if we have some people who are responsible for moving the entities and the parts around, all those can be considered as move times. One other thing is that here, let's assume I tell you that the move time is not exactly 3 minutes. Is 3 minutes exponentially distributed, let's say. then all I need to do is to come here and just say move for, let's say, E3. Okay. So then the move time is not fixed 3 minutes, it's 3 minutes on average exponentially distributed, or 3 minutes on average normally distributed with standard deviation of 1. Okay, you just write that in N31. So if it's not fixed, if it's random, no worries. You just change it to random values, the random variable. If the move time for between some locations it is different from the other, again, no worries at all. Just make sure for movement between every 2 locations, put the corresponding time, and that's all you need to do. Okay. So I put the new move time, which is E exponential 3 minutes for all the moves that happens in the system. Again, except the one where I go from the packing to exit. I don't need any move logic, any move time for that one. I changed the rest of the move times, and then let's run it one more time. Okay, and you see here, now the move time is 6.01. It's just a little different because now these move times are coming from the random variable with average 3 minutes. So if one is a little higher or lower than 3, that's fine. Anyway, at the end, the sum is about 6 minutes. Okay, so that's the reason that they are coming from this random variable is the reason that I don't see the fixed exact 6 minutes, which is perfectly fine. But still the move time, the move time is there, and the total time in the system is the sum of the move time, the time in operation, wait time, and now I want you to save your model as a new model in the same folder. Give me 1 second. And at the end of the name, put move with resources. Okay, save it as a new model, and at the end of the name, put move with resources. So what do we want to do here? So far, I considered the move time, but I assume there is no resource that does the move. So I again assume that, okay, there is some move time, but the part just goes from one location to the other location itself without any help. However, again, in a lot of real world problems, that's not the case. We have a worker that is in charge of moving the parts around. We have maybe a forklift, a robot, something like that, that is moving parts from one location to another. So if that's the case, then we can capture those as a resource in our model. We want to capture them because then how many resources I have affects the performance of my model. If I only have one person that is in charge of moving parts around, so let's say that person takes one part from material receiving and goes to inspection. And right now, the inspection 2 is done with the part. So the part has to go to the packing, but we are waiting for this resource to come and take the part to packing. However, if the resource is busy taking the part to inspection 1, then the part in inspection 2 has to wait till the guy finally is done. Then the person comes to inspect 2 and then takes the part to packing. Okay, so that resource that is in charge of moving parts between these locations can be a bottleneck itself. If we do not have enough resource, then the parts have to sit where they are done till the resource is finally available to come and take them to the next location. Okay, and if that's the case, which is quite possible in a lot of systems that use resources, either people or forklifts or robots or things like that, when these resources are used for moving parts, it's absolutely possible. If we do not have enough of them, it's absolutely possible that they become a bottleneck in our system. So the process just takes longer simply because there's not enough resource to move the parts around to different machines. So although they are done at one machine, they have to just sit there till the resources available to take them to the other location. So now we want to see how I still can capture the move time, but here some resources are used to perform the move. So if that's the case, then I need to define a resource. And to be able to do that, I go here, resource. Yeah. So I go to the resource. So click on the resource here. You can pick any icon to represent your resource. Say I pick this person and I call it, let's say, worker, or any name you want to give to it. I have one resource and do not change. If I have more than one worker that is doing this job, I can increase the number of units. But here I'm assuming I have only one worker in charge, okay? Do not change anything else. So that's because it's my resource. If you're using the 2016 version of ProModel, you can get to the resources under the build menu, okay? But if you're using 2018 version, it's perfect, it's right in front of you. Define the resource, and now let's go back to processing again. And here, in the move part, now I'm going to change this code that I wrote. And this time, if you want to have an easier time, I would recommend double click on this window. So let's assume this move window is not open. So double click here on this move window, and then this code, this window opens where you can write your code. And as you can see, whatever we wrote in this little window is now shown here, okay? Okay, so what I wanna do here is move with resource. And when I named my resource as worker. So as soon as I type W, the name of the resource appears here. And I always recommend to pick the resource from this menu, because when you type, there is typo and things, so you get a lot of errors and you don't know what's going on. So when you see the name of the things that you have defined, just pick them from this menu to be on the safe side. So move with the resource, which I called worker, for E3 for whatever amount of time, 3 minutes, E3, normal, 3-1, whatever it is. Okay, so move with the resource for this amount of time, then free. This is an important keyword. So all the blue things here are keywords. They have to be there. Otherwise, your system is, you are going to get error. Then free is important, because what this tells the simulation is that when the resource moves one part from one location to another, then free the resource so that the resource can go to other locations and move other parts. If you forget to put then free, you do not get the error, but you don't see any exit because your resource is stocked in that location and is not available to move other parts. So you do not see any exit, but you don't know what's going on. Okay, so do not forget to put then free if you're using resources to move parts. Okay, so move with, those are keywords. The blue parts are keywords. Your name of the resource, worker here, for whatever amount of time, random or fixed, then free. So that's how we have to write this. So copy that. And we are going to paste it in all the locations where we had a move, except the line where we exit the system. Okay. Everyone is good? Everyone is done? Now let's run the model again. Now again, if I go to the table summary, to the entity summary, again, I see the time in the system, the move time, and the time in operation and the block time, okay? Also, you see here, there are some orange part, and when you click on that is percentage waiting, which we did not have before. Previously, we only had percentage in operation, idle, meaning that machine is not working, and then block. But now I have a new part, waiting. And what is the meaning of that? So this represents the scenario when inspection 1 or 2 or 3 are done, they're done with the processing. They are not blocked by the next machine. The next machine is idle. They can send the part to the next machine. However, they cannot do that because the worker is not available to take the part to the next machine. So they are sitting, holding the part, waiting for the worker to come and take the part. Okay? So that's what these orange parts show. That's the percentage of time that the machine, inspection 3 machine, is not be able to work, not because it's processing a part, not because it's blocked by the next machine, but because it's waiting, holding the part till a worker is available to take the part to the next machine. Okay? So be mindful of what these colors mean and how they are interpreted, and potentially if you want to increase them or decrease them. Also, pay attention that if I go to location summary, the utilization that I see here, the utilization that is reported in the last column, is actually the sum of operation time, the percentage of time in operation, and block time, and waiting time. Because in all these situations, the machine is not able to work, either because it's processing a part, or because it has to hold the part because the next machine is busy, or because it has to still hold the part because the resource is not there to take the part to the next machine. So the simulation treats all of these green, pink, and orange parts as utilization. So again, when you report the utilization, make sure you're mindful of how that number has been calculated and which parts are the ones that you want to get rid of and which parts are the ones that you want to increase. Okay. So then we learn to capture the movement in 2 ways. Either move for some time when we just want to capture the movement, not the resources that are performing the movement. And then the other option is when we have some resources that are performing the movement. So in that scenario, this is the line of the code that we have to write. Move with the name of the resource for whatever amount of time, then free. The blue terms are key words. They have to be written in that order. And if you miss any one of them, you get error. Also, when we use this part of the code, this part of ProModel to write the code, you can always use this button you see, compile, to compile the code that you write here. If I press, it just compiles and it says, okay, compile successfully. And that's good because later we will learn, actually we write lines and lines and lines of codes here. So it's always good to compile them right here before we go to the next section of the model or to the next line of the model, because if we just don't do that and leave everything to the end, then suddenly we have tons of errors. But if we compile them piece by piece as we go through the simulation model, it's always better, safer, and takes less time to debug. Okay. Make sure to save, guys, as we proceed. Any question?
Thank you.
Professor?
Yeah.
I think like the number of X's, the difference between mine and yours, which is mine is also 819, I think, is that in your model, one time in the inspection 1, you changed it to N12.3 for the first inspection.
Yeah.
And we're supposed to keep it at 10 or change it as well?
Yeah, it doesn't matter, honestly.
Oh, okay.
That's not the point.